As an individual consumer, you might not think about how much energy or water it takes to summarize an article with GPT or to generate another cat meme. But companies that want to scale generative AI use cases and report on their carbon emissions and costs have a lot to think about. So, how does generative AI use affect the environment, and what work is being done to reduce impact while still generating that value? That's what we'll talk about today on The Generative Edge. Today's guest, Kristof Schum, is the former AWS Energy Segment Lead and now Regional Generative AI Partner Lead for AWS Europe, Middle East, and Africa. Welcome, Kristof.
Nice to meet you. Thanks.
So, our first topic today is going to be about the water and electricity consumption of generative AI systems or AI systems in general. I know that this is a huge topic because it draws a lot of power, and a lot of our energy consumption comes now from AI and generative AI increasingly. What does that look like at AWS in your line of work?
It is indeed. It's a considerable amount of power, but and water as well. Let's go into the details. But the way I actually like to describe it is, oftentimes it is called the elephant in the room. I like to call it the ant in the room, and not to belittle the amount, but actually just to. I think it's worthwhile taking a magnifier glass and looking at it. How is it harmful? How useful? How much is it? And then, so that's why that's what I like to do to do with that. And then there's a couple things that come to my mind. But first and foremost, we treat responsible AI, responsible generative AI, very, very seriously. So we'll discuss a lot more what we do with water, what we do with electricity, how we improve. But that is first and foremost that we have. So in AWS is Amazon actually is a very leadership principle oriented company.
Mm-hmm.
And a few years back we added two more. And I'd like to, if it's okay, I'd like to actually start with reading that, and it's less about
Yeah, go for it.
okay, that's how we work, that's how we think, that's how we wake up. So we have added that success and scale brings broad responsibility, and then so we started at a garage. We're not there anymore. We're big, we impact the world, and we are far from perfect. And I think actually this is true for Deloitte as well. Big, impact the world, and obviously we should like aspire to do everything better every day. We must be humble and thoughtful about even the secondary effects of our actions. Our local communities, planet, and future generations need us to be better every day. We must begin each day with a determination to make better, do better, and be better for our customers, our employees, our partners, and the world at large. And we must end every day knowing we can do even more tomorrow. Leaders create more than they consume and always leave things better than how they found them. So I just wanted to preface that because we aspire in water, for example, we have a water plan by 2030. We have a plan to be water positive, to give back more than what we withdraw. In electricity, we have the same plan we can go into. So that's what's foundationally driving everything that we do at
Mm-hmm.
AWS. Yeah, well, I'm curious actually. What do you think? What do you think about the high level water and electricity usage?
High level, I think it's we're probably headed in the right directions in some cases. I know that because the technology is so new and so many people are trying out things that may not be the most efficient way to do it. Like for example, if you're using a generative model to do like simple text classification, like we know that the generative model is going to be way less efficient at it, but it makes it so much more accessible to people who don't have any experience in AI. So it's not necessarily the problem that, like, okay, the technology is new and therefore it's so inefficient that it takes too much power or water, but there are other ways of doing the same type of work for most of the things that we're now currently using it for. So, like, a lot of the use cases are still just text classification or extractive question answering, that kind of stuff. And the truly like generative based use cases, that's where we basically need to understand how much energy do we need in order to do those things, and then what kind of work is being done to reduce the energy required for those tasks.
Uh,
Um, yeah.
I couldn't agree. I couldn't agree more. And I wish if there's one thing that I like personally, I'll be honest. I don't like the blind scapegoating. And what I mean by blind scapegoating is generative AI is trending. It is all over the news. It's all over the business discussions. And um the question I raise is, why weren't we so economically precise and sensitive for the use of video conferencing, for the use of for the use of using the microwave, for the use of a- and so what I hope is that with the current scrutiny, we will actually start to think differently, to start to think with a green ROI lens, not just on, should I summarize this with a large language model, but also, okay, like what am I gaining from 1 hour video conferencing, for example? So maybe it changes. If it changes the mindset of people, I couldn't be happier. So for instance, there has been a few interesting studies that were how thirsty is generative AI, how much electricity does it actually consume,
Uh-huh.
and while I agree that this was actually a lot, that we have to acknowledge that training one of these large language models is a massive effort, computation wise, not just computation wise, but it has lots of overhead and hardware. If you take an example, we know there was a study done, it's publicly available on Bloom. It was trained on 175 billion, um,
Parameters?
the number of dimensions,
Yeah.
parameters. Yes, yes,
Hmm.
yes. And then, and it took about 3 months to train. And it was using, I need to check, but I think it was using, I don't know how many A100s. It was about 2.5 million cores. Um, so that is 450,000 kilowatt hours. That's about seven US household uh all year round. So that's a lot. To bring to the light is that one, there has been actually projects in the world of high performance computing that was similarly large. So in fluid dynamics, the HPC clusters, these computers like Summit, Sierra, they were using similar amounts of energy. So it's not that it is new. It just got the limelight, and then it is a lot. But the question is how we are using it and how we are aiming to reduce it. I think
Right. Yeah.
that's my point.
And there's two pieces of this puzzle also. There's not just the companies that are doing it by building out these like, automated solutions or agents or whatever, but there's also the consumer market where people are subscribing to OpenAI and they use these models, and accounting for the energy needs of not just the enterprise market but also the consumer market, which are doing two totally different things. If I could tell you the number of like memes that I've seen generated on Facebook from generative models, accounting for like how much new energy needs to either be produced or used, by like data centers and stuff, just because of the consumer market, which is not as easily regulated as something like the enterprise market. That's a huge open question, I think.
Absolutely. And well, what brings to mind is the difference, I think, between the inference and training, because what we see, and it's especially true for Gen AI, is that with machine learning, about 80% of the use is with inference. So these huge training for 3 months draws a considerable amount of energy, um, is 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 actually true for a smaller portion. The biggest question is how and how consciously we are actually using it when we are making a summarization, or when we are, is it in the, how the consumer market uses, how does the enterprise market uses, how, so I think that's a super interesting question.
Hmm. Yeah. I really like the response of academia at this point. There are so many papers coming out just in the last year or two alone. I can think of one off the top of my head from UC Davis, where they were trying to implement some kind of model that's trained without any matrix multiplication. And for our non-technical listeners, matrix multiplication is just a mathematical operation. It takes up a lot of the compute necessary to like train and run inference on these models. And they were able to create a model architecture that trains with the same efficiency or the same performance as one of these traditional large language models without any matrix multiplication, and it had something like a 60% reduced usage in energy. And that's just one example. There are so many examples of other people coming up with different machine learning architectures that reduce energy consumption, that decrease the time from pre-training to inference, things like even engineering feats, probably I guess a lot by NVIDIA, that are coming up with these new GPU architectures that really are high throughput, low energy for large language models. And I think that response, this like academic and engineering response to the energy needs, is really, it's cool to see, because it shows you like one approach to actually solving that issue.
Exactly. One if I may follow up on that, one example that one of the most visible ways how this innovation and more critical thinking can bring power efficiency is that even it happens in the chipset. So AWS has a chip family called Graviton,
Oh yeah.
and it delivers it's a high performance with high levels of energy efficiencies. For example, the Graviton 4, it is 30% better computing, 50% more cores, 75% more memory bandwidth, but then it
Wow.
is actually it's at the far better energy efficiency
Mm.
than using anything on EC. So that is one way. The way I like to actually describe that is there are almost at every step of using Gen AI, there's an optimization potential.
Yeah, yeah.
For example, the first step is what I call the business scope. Should I use it? Is this the right technology? Am I going to get the right return? As I've started with the leadership principle, do I get more out of it than what I actually put in?
Yeah.
So even there, this is I think this optimization is present. Then when with the model selection, the second piece is the model selection. Should I use that huge model or no? Actually, like a slightly like lower performance model, but far more energy efficient model is possible.
Gotcha.
But the third one is even we can optimize. For example, we have colleagues working on prompt compression. With prompt compression, do we need to ask this huge text, or we can actually apply mathematics to shrink it
Yeah.
and use less energy? Or quantization. Should we can quantize the model, we can shrink it and use that. So there every step of, and then the infrastructure we use, a part like the sustainability pillar is one of the pillars in our well architected in
Yeah.
the AWS well architected architecture. So every step of the line, we should use any optimization that is available.
Right, exactly. In addition to all those optimizations, where or do you know how you source that energy? If you're looking for particular, I don't know, thresholds for renewable energy usage or where the water's coming from, that kind of thing?
I know only for AWS. And for AWS, we source the majority of the AWS data centers coming from the grid,
Mm-hmm.
but it is for 22 regions, it is 100% renewable. So we had AWS and Amazon in 2019 was one of the co-founders of the Climate Pledge. So ahead, 10 years ahead of the Paris Agreement, by 2014, achieve carbon net zero. And we actually wanted to be 100% matching 100% electricity by renewables by 2013. And actually, we are pretty proud that we have achieved that 7 years ahead last year. So in 2023, AWS was 100% matched with renewables. Now, it doesn't mean that we have in locally present. So every data center is running from a locally present uh, renewable project.
Right.
But through our power purchase agreements, we purchase actually for the fourth year in a row, Amazon has been the world's largest corporate buyer of renewable energy. So we source that, and that's how we achieved 100% electricity from renewables. So yeah, that's how we power our data centers.
Gotcha. Okay, thanks. So I don't know how technical you are, but do you know what like parameter efficient fine tuning is, or you obviously mentioned quantization, which is another way of like
Quantization,
yeah,
yeah.
exactly. So are you familiar enough with like PEFT that you can talk about how maybe AWS is helping its clients to understand how to make those efficiency gains or those optimizations, the computational optimizations, the quantization, et cetera? Or do you know of any programs that are basically helping other companies to adopt the technology faster and more efficiently rather than leaving it up to our own devices? Is that something that you guys do?
We're starting to, and we started, as I mentioned, actually we started at the infrastructure level. Uh, from the application wise, we I think we don't yet do enough. We don't yet do enough. We While last year was the year of the proof of concepts, and this year is the year of production, we still explaining the basics of this entire flow: business scope, model selection, how do you architect, how do you deploy, um, and optimization throughout each step is is not yet, I think, sufficiently in the focus of. Obviously, we have our data scientists in our AWS ProServe. We have the wonderful scientists in our system integrator community, such as yourself, who are experts in that and help the customers. But from the customers, I don't see it yet happening. What I do see happening is a desire for cost reduction.
Oh yes. Uh
And
huh.
I think through that we will get there. We will get to parameter optimized fine tuning, for
Gotcha.
example.
Yeah. I mean, I don't want to sound too like not optimistic, but I guess a lot of the efficiency gains and the optimizations and stuff they're primarily in the enterprises driven by this desire for cost reduction rather than like outright wishing to use less energy or something.
Exactly.
But of course,
Exactly.
energy is expensive, and so the business case is we need to use as little energy as possible to get whatever we need in the business side of things. So. Um, yeah, I guess that's not too apocalyptic, I hope. I see the problem also here, like in consulting, any client that I work with who wants to implement generative AI, you don't know what you don't know. And because it's so new and there are so few people who spend their time, reading science papers and understanding what
Yeah.
matrix multiplication is or what like GPU architecture does for energy efficiency or whatever, there are so many parts of this pipeline that need to be looked at from a cost perspective that it's impossible to provide all that expertise with a single person or sometimes even with a single team. And of course, if your company is just getting into the AI game, there's so much to learn. So I think that a lot of those optimizations are probably going to lag behind the adoption of the actual use cases. But it's an area of really interesting, very cool ongoing work that is kind of exciting to be part of.
I agree. And I don't necessarily think that the business leader should know that a like a graviton processor is running the reduced instruction set computer versus a
No.
complex
Can you
instruction set
imagine?
computer, or a logical core versus a physical core,
Uh huh.
but should have the mindset
Right.
that
Mm-hmm.
how do I cost optimize? How do I optimize for carbon footprint emission? What's my electricity use? And that's why, for example, I'm curious. I've read that a simple search, a Google search, costed 0.000, like five zeros and a three, I think, kilowatt hours.
Yeah.
And if we use a large language model powered one, it's about 1,000 more
Yeah.
expensive. So we should be aware of that. But I'm actually even curious that I looked into that how much an hour of video conferencing
Yeah.
costs. And actually, it is pretty much on par as that more expensive LLM powered search.
Wow.
So we should be conscious, I think, everywhere. And
Mm-hmm.
that's why I mentioned that if we bring in that consciousness, the business leaders bring in and have that consciousness that, do I get the output from this video conference? Do I get the output from this summary, then it's already a huge step forward.
Gotcha. That's an excellent point. Not to mention all the efficiency gains that we assume that will come from using AI. So like the reduction in,
Exactly.
time to market or whatever.
Yeah, I'm curious. I'm curious. What was your most interesting use case that you found that this was used, or anything that even in linguistics, for example, how you found, and then was the cost implication in your head or not yet? There needs to be tuned or improved a little bit.
I would mention maybe two use cases. One which was really good from an energy perspective, and one which was really bad, I think. So the first one was this summarization tool. Like one of the really easy, like very clear cut use cases is abstractive summarization over some text using a generative model. They're really really good at this. For a group of like risk advisory people, we basically made this web app where they just put in the text from a news article and it summarizes it according to their rules. Just implementing that one tool reduced their overhead costs by 70%. It reduced the amount of time to generate a summary by 98%, which means that a lot of their time was freed up to do other work. And the energy usage is minimal. It's like very very small because the text generation stuff can be done with less than 1% of like a phone's charge, for example. But then we switched to another use case, which was ingesting a lot of unstructured data. So like tickets and documents and SharePoint folders and that kind of thing, doing the pre-processing, vector embeddings, and it's basically like a typical RAG search system, and then a question and answer bot on top of that RAG system. So the RAG system itself, not super expensive. Doing the like vector search is a little bit more computationally intensive, but not so bad. But then you add the question and answer bot on top of it, which is incredibly inefficient because it has to sift through tens or 20, 30 documents or something to find the correct answer. And it can cost upwards of like 40 cents to answer a single query, depending on the quality of the data from the underlying database, which is really, really expensive. You do not want to have a chatbot that costs 50 cents to use every time you ask a question, right? And you don't really see those costs until you actually try it out and you're like, okay, what are all the steps that I need to do in order to get my data from a Word document into something that's usable, like Google does with its AI searches. So those would be the two examples that I would give. One where it's like very clear, there's a good business use case for it. You free up a lot of people's time, and there's like a negligible carbon cost. And then you go to something that's much more large scale, and it's just incredibly inefficient. Yeah. Mm-hmm.
I like that 1% of a charge, or even you mentioned the if we assume that one question, the inference for these large language models are in the single digit cents, then what's the output that we get from that? So for example, when we started researching generative AI, one use case was in the image generation. Just let's just move away a little bit from the text, and then to make a listing online for any e-commerce company, to make a 3D model, it costs $100 per SKU. There's lots of photos, with generative AI, it costs $5.
Mm-hmm.
So do I get that reduction in efficiency?
Yeah. Mm-hmm.
Is it that is in the mind? So, or if it's in the single digit cents, then do I get we have a few customers like the New York Stock Exchange. They simplified the trading rules, and instead of digging through the trading rules or going into complex legal problems, avoiding that. So do I get the return, or similar like with Pfizer, where we have reducing the actual time new medicine is being brought to market? Then I think we should always keep that ROI
For
from
sure.
a green ROI standpoint as well. So I
Yeah, for
couldn't agree
sure.
more. Use
I've
case dependent.
I've seen some science communicators also look at it from a different perspective, where if you have a job that's typically done by a person, let's say painting a picture or something, or digital art, just putting a meme together, right? It takes a person a specific amount of time, and to do it 1,000 times, they need much more time. And just being alive, you're exhaling carbon dioxide. You're leaving some kind of carbon footprint. You need to eat and drink water, etc. And it's so hard to model the difference between what a person is going to use to do something 1,000 times versus a machine doing it in a very short span of time. Maybe it is the same amount of energy, or maybe it even is more efficient. But the fact that you've scaled up, and it introduces this new dimension of what you need to calculate, right? Because if you generate 1,000 images for fun, it's different than somebody sitting there and then making money off of 1,000 images that they painted.
Yeah. Yeah, absolutely. Absolutely. So it's just like in the way, be responsible. So be knowledgeable. Everybody, every business leader, every technical leader, I think if you're responsible in a new sense of all the aspects of, actually, we didn't even touch on it. I have this social aspect besides the environmental aspect, but even just environmentally, if you're responsible, that like, do I leave behind more what I consumed, is already that's it. I think we with Deloitte, we will solve the majority of the rest with the underlying infrastructure being optimized, with helping others to architect for higher energy efficiency. But we need the other counterpart to think responsibly, consume responsibly, educate themselves.
Sure. Definitely. I love that. Okay. I think that is a great optimistic note to end on. So I wanted to thank you for your time. Thank you so much, Kristof, for being with us. And thank you for listening to The Generative Edge. We'll see you next week.
Thank you for listening to The Generative Edge, a Deloitte Central Europe and AWS production. Your hosts are Brandon Eychaner, Vyasaraj Kulkarni, and Donovan Spronk. Our show is executive produced by Stephanie Cohen, Vanch Luthra, Ian Masters, and the Deloitte studio in Prague. Head writers are Stephanie Cohen and Brandon Eychaner. Our sound and audio engineer is Wojtek Krasa, who also serves as our editor and videographer. Michal Trusina is our graphic designer. Our marketing and social media managed by Stephanie Cohen and the Deloitte studio in Prague. And our theme song was written and produced by Jakub Flaszek. Don't forget to rate and subscribe on Spotify, Apple Music, YouTube, or wherever you get your podcasts. Thanks for tuning in.